This is Algebra 2, Unit 4, Lesson 7, and today we're going to talk about synthetic division. I've got the method for synthetic division here. It would be a good idea for you to write that in your notes so that you have the method written down, and then we will do some examples. So go ahead and pause the video, write this board down, and then I'll show you how to do the process. The first thing we're going to do is write the coefficients of the dividend in descending order, and don't forget the zero terms. So here's an example. We've got a polynomial here, and we've got it divided by a binomial here. With synthetic division, you are always going to have a polynomial divided by a binomial. I don't know that synthetic division works otherwise. I've never seen it done that way. So if you have something other than a binomial on the bottom, you will have to use long division, which we've learned in the last lesson that long division is very time consuming. So anytime we have something that will save us time, that's what we want to use. And synthetic division saves you a huge amount of time when you're dealing with division of polynomials. So that's why we're learning it. So what this step number 1 means is we're going to take the polynomial that is being divided into the dividend, and we're going to write down all of the coefficients of the x terms. We have to make sure that there aren't any x terms missing. In other words, if it starts with x cubed, we have to make sure that x squared term is there, the x term is there, and the constant term is there. If any of those terms are missing, then you need to put a coefficient of a 0 in for that missing term so that we don't miss that part of the polynomial. It's very important that that's included. So with this one, we've got a 3, 2, 1, x to the 0. So we've got all the terms included. So we don't have to have any zeros in my first part. So I'm just going to write those. A 5, negative 13, 10, and negative 8. So I pay attention, whatever the sign is of the coefficient, I make sure I put with the number down here. And then I'm going to do a little box right here. And this is where my divisor is going to go. And the divisor, understand, is x minus 2. But what we want to do, we want to pull the r out of that binomial. Okay, so what we need to look for, the divisor must be in the form x minus r. In other words, it has to be a variable minus a number. R will be a number, okay? And that r number will go right here in this box. Okay, so if we look at this, luckily that one's in the correct form, x minus 2. So that means r is a 2 there, not negative 2, but positive 2. Now, I do want to point out, let's suppose that had been x plus 2. If that's the case, then r would be a negative 2 because x minus r would end up being x minus negative 2. So r would be negative 2. So you have to pay attention to the sign. If it's x minus a number, that number goes right there. You don't have to worry about any negatives. If it's x plus the number, then that number, the r number, would be negative. That takes us to step number 3. We're going to multiply, add, multiply, add, multiply, add, multiply, add till we get to the end of the problem. Okay, so we're just going to continue that process until we get to the very end of the problem. Now that will make more sense as I do the example. But what I'm going to do is on my paper, I'm going to leave a line here that's blank because I'm going to be ending up putting numbers underneath here. So I'm going to leave a little space. I'm going to draw a line, and then I'm going to bring down my first number. So now I've set it up. I'm ready to do the multiplication and the addition. So here's what you do. You do 2 times 5 is 10. Put that number there. So I multiplied. Now I'm going to add these two numbers. Negative 13 plus 10 is negative 3. Pay attention to your signs. Then I'm going to multiply again. 2 times what I got, negative 3, is negative 6. Then I'm going to add. That would be 4. Then I'm going to multiply those. That's 8. Then I'm going to add. That gives me 0. Now, if you get 0 at the end, what that means is this polynomial has no remainder. Whatever you get here is going to be the remainder of that division problem. So then the next thing we need to do is look at number 4. It says write the quotient as a depressed polynomial. Okay, the depressed polynomial, what that means is whatever degree we started with, the degree of the answer will be one less than that. So my coefficient of the first term in my answer is going to be 5. It's going to be 5x, because that was the variable we had here. And it's going to be, we're going to decrease the degree by 1. So that's 5x squared. The next term will be minus 3x. And the next term will be plus 4. Okay? So that is my answer to this synthetic division problem. So we're going to do several more of these examples to make sure you're understanding synthetic division. In this one, I'm going to set up my polynomial. So my coefficients of this term are 1, -2, and -15. I'm going to set up my box. This is in the form x minus r. My r here would be 5. I'm going to leave a little space. I'm going to bring down the first number. Then I do multiplication. 5 times 1 is 5. And I will add. That's 3. 5 times 3 is 15. And then I will add. That's 0. So for this one, my depressed polynomial, this started with x squared. So my answer will start with x. So 1x plus 3. Whatever sign is in front of it is the sign you put here. So that division problem gives me x plus 3. Well, with that one, we could maybe check that with factoring. Let's see if that works. Factors of 15 that subtract to give you 2, -5, and +3. The minus 5's cancel, leaving me with x plus 3. Okay, now certainly, if I had that problem on a test, and I was told to solve it, I wouldn't use synthetic division. I would use factoring because it's faster and it's easier, okay? But it's all in what you're comfortable with. I want you to get the right answer, and I want you to get it the most efficient way possible. So I'm trying to give you options here, giving you different ways to do it. The bad thing about factoring is it doesn't always work. So synthetic division gives you another fairly easy, fairly simple way of doing this. All right, so in the next one, this one's a little bit different. This one has a few more details that we need to pay attention to. If you look at this polynomial, to set it up, in my little box, I'm going to have a 2. I have my coefficients, 1, -4, 6, -4. My degrees went 3, 2, 1, 0, so I'm not missing any terms. I don't have to do any zeros. I'm going to bring down the 1. So at this point, go ahead and pause the video, see if you can finish this one, see if you can write down your depressed polynomial and get that correct before we get into the special cases. I want to make sure we do some of those. Okay, so hopefully you finished this. I'm just going to go through real quickly and do this. 2 times 1 is 2. If I add those, that's -2. 2 times 2 is -4. Add those and get 2. 2 times 2 is 4. Add those and get 0. So again, this one had no remainder. My depressed polynomial will be x squared minus 2x plus 2. And that would be my answer. Okay, this one is a special case. Remember, you have to pay attention to 2 things. Make sure all of your variables are included. In other words, they're all in descending order and you're not missing any of the terms. So this is a squared, so a 2, 1, 0. So we've got all the terms there. And then you have to make sure that your divisor is in the form x minus r, or a variable minus a number. Okay, well look at this. This is not a variable minus a number. This is a number minus a variable, so it's backwards. Okay, we have to have our variable in the front in order to be able to do this one. So I want to switch that around. So that's the same thing as -a plus 2. Okay, and then I still have a problem here because it has to be in the form x minus r, a variable, a positive variable minus a number. Well, we have a negative variable plus a number. Okay, so we have to account for that and we have to take care of that. Now, when we do that, we can make -a positive by dividing it by -1. So that's what I'm going to do here. I'm going to divide this by -1. And when I do that, I end up with a minus 2, okay? But there's a problem with that. I've just changed the value of my divisor because I divided it by -1. So if I divide my divisor by -1, I also have to divide my dividend by -1. As long as I'm doing the same thing to both of them, it's really like I've multiplied by -1, okay? So I can't do it to one of them without doing it to the other. I have to make sure that I'm doing the same process to each of the portions or each of the parts of the problem. So I need to divide that by -1, which essentially is the same thing as multiplying by -1. So I could say I'm multiplying it by 1, which is -1 over -1, or I could say I'm dividing it by -1 over -1, okay? Same thing. Whether you divide or multiply by 1, it doesn't matter. You're going to end up with the same thing in this case. Okay, so if I divide this, I have a -a squared plus 5a minus 3. And so now this is my new problem. Now my divisor is in the form of a variable minus a number, and my dividend, what I'm dividing into, has been divided by the same number, so which is essentially multiplying by 1 or dividing by 1. And that allows me to have something that is the same value but looks different. And it looks the way it needs to look in order for this process to work. Okay? So we didn't change the value of the problem because we did it to both parts. We just made the problem look different so that we could use the process. All right, so I'm going to set it up. I'm going to do my box. My R value here is now 2. My coefficients are -1, 5, and -3. Notice, after I've divided by -1, I don't use this part anymore. I'm using my new information now, okay? I'm going to leave a little space. I'm going to bring down the -1. I'm going to multiply, that's -2. I'm going to add, that's 3. Multiply is 6. I'm going to add, that's 3. This one has a remainder, which is a little different. So now that I have a remainder, what I need to do is I need to still write my depressed polynomial. Well, when I do that, that's a -1, so that's negative. And that depressed polynomial, we started with a squared, so it'll be -a, okay, plus 3. And then my remainder was a positive 3. Now remember, when we have a remainder, didn't we put the remainder over the divisor? So I'm going to have, that's a plus 3 over my divisor, and my divisor was a minus 2. So this is the answer to that synthetic division problem. So look at the other one behind me. It also is a little bit different, and there are two things that we need to pay attention to for this one. Not only is this not in the form x minus r, we are also missing the x cubed term. Not only will this one have some zeros in the dividend part, I also have to change my divisor so that it's in the right form, x minus r. So what I'm going to do first is I'm going to change my divisor. I've got to get it looking right first. So in order to do that, think about it. What do I need to divide by so that the x term, the 2x, becomes an x? Hopefully you're saying 2. You got to divide by 2. So if I divide 2x by 2, I have to divide that entire term by 2. And in order to not change the value of this problem, if I divide the divisor by 2, I also have to divide the dividend by 2. I have to divide everything in the entire problem by 2. So essentially, I've just divided it by 1. I'm not changing the value of the problem. I'm just making it look different. Okay, there are going to be a lot of times in math where you have to make your problem look different so that you can use the information that you have. All right, so if I divide everything by 2, I'm going to have 4x to the 4th minus 2x squared plus 1/2 x plus 2, and that will be divided by x plus 1/2. So now, here is my new problem. So when I set this one up in my little box, think about this. This is x plus 1/2, and it's okay for r to be a fraction. There's nothing wrong with that. A fraction is a number, okay? So x minus r is the form it has to be in. So wouldn't this be x minus negative 1/2? So my r value is negative 1/2. And then I put my coefficients down, accounting for my zeros. Now, this is the most common mistake with synthetic division, is people forget to account for the zeros and end up with the wrong answer, okay? So we have to account for the zeros. So the coefficient of the first term is 4. The x cubed term is missing, so the x cubed term is 0. The x squared term is negative 2. The x term is 1/2. The 0 term, or the constant, is 2. I leave a little space. I bring down my 4. And then I start the process of multiply, add, until I get to the end. So, negative 1/2 times 4 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 1/2 is 1. Negative 2 plus 1 is negative 1. Negative 1/2 times negative 1 is 1/2. 1/2 plus 1/2 is 1. Negative 1/2 times 1 is negative 1/2. And 2 plus negative 1/2 is positive 3/2. Okay? So in this one, my remainder is 3/2, or 1/2, same thing. I tend to keep them top heavy because it's going to make it easier on me later. You'll understand why in a minute. Now, for all of this addition and multiplication, if you're not comfortable doing fractions in your head, no big deal, just use a calculator. You're going to have the calculator available for you for most tests that I know of that you'll have to take. So it's okay to use a calculator. It's good for your brain to use it to do fractions sometimes, but if you're not comfortable making sure, and you want to make sure you got them right, go ahead and use that calculator. It's okay. All right, so now I'm going to write down the depressed polynomial. I've got 4x cubed, 4 because 4 was the coefficient there. Cubed, x cubed, because we started with x to the 4th. The depressed polynomial goes down by 1 degree. Okay? Minus 2x squared minus 1x plus 1. And my remainder is 3/2 over my divisor, which was x plus 1/2. Now there's a problem with this. This part is fine. We can leave it. It is part of our answer. But this part, we have a problem. You have a fraction over a fraction, okay? Within a fraction, when you have fractions on the numerator and fractions on the denominator, if you have a fraction within a fraction at all, whether it's just on the numerator or just on the denominator, you can't have that. That's called a complex fraction, okay? If it's a complex fraction, you have to get rid of the fractions within the numerator and the denominator, okay? So with synthetic division, they're always going to be pretty easy to take care of, because if you think about it, how can I make 3/2 a whole number? Can't I just multiply by the denominator? And if I do the same thing on the bottom, if I multiply by the denominator, wouldn't I be multiplying by the same denominator? So if I want to get rid of the 3/2, I'm going to multiply by 2. If I want to get rid of 1/2, I'm going to multiply by 2. Since those denominators were the same, and they always will be in synthetic division when you have this situation, but since those denominators are the same, isn't it that's going to be the same thing then if I multiply the top by 2 and I multiply the bottom by 2 as multiplying by 1? If we multiply anything by 1, we're not changing its value, we're just making it look different. We're making it what we need it to be able to count it as our answer. So if I multiply by 2 on the top and the bottom, essentially all I'm doing there is multiplying by 1. I'm allowed to do that. So if I multiply by 1 here in my remainder, I have 3/2 times 2 is 3. X plus 1/2, and I do have to distribute that, would be 2x plus 1. Okay? And if you notice, when you have this happen in synthetic division, that 2x plus 1 ends up being the same thing that our divisor was to begin with. And that's always going to happen in synthetic division. The rest of my answer, I just bring down. And this is the answer to that synthetic division problem. Here I have two synthetic division problems. I want you to try these on your own and see how you do, then we'll go over them together. So go ahead and pause the video, write these down, show all the work, and then we'll check them in a few minutes. Okay, so I have the answers here for you. When I set this one up, that was already in the form x minus r, so I used a 2. My coefficients were 1, -4, 6, and -4. And then I just did the multiplication and addition there. Ended up with the depressed polynomial x squared minus 2x plus 2. In the next one, this one I had to make sure I divided everything here by 2 because it has to be in the form y minus r, or x minus r, variable minus a number. So I divided everything by 2. Over here, that left me with y minus 1/2. Over here, that gave me 2y to the 4th minus 5/2 y squared, or plus y plus 2. Then when I set up my synthetic division, in the box I have a 1/2, and then here I have a 2, I have a 0 because my y cubed term was missing. And then I write the rest of the numbers. I bring down the 2, and then I do multiply and add until I get to the end. Again, if you're uncomfortable with doing fractions in your head, use your calculator. So my depressed polynomial became 2y cubed plus y squared minus 2y plus 2 over y minus 1/2. That is a complex fraction, so I had to get rid of it by multiplying by 2 over 2, or 1. When I do that, I get 4 over 2y minus 1, and so there is my answer. So hopefully you're understanding synthetic division pretty well. Again, if we can use factoring to simplify polynomial division, we would always do that first, but then synthetic division gives you another quick, simple method to use other than long division. Long division we're only going to use as a last resort if nothing else will work.